Hi everyone, this is Applied Math for our welding group, and today we're going to kind of walk through the PowerPoint for ratios and do some examples and see how things work. And so let's go to that PowerPoint. And if we're looking at ratios and proportions, we see ratios all the time, or at least they are out there. You just have to realize that they're out there. And ratios occur frequently, a lot of times when you're mixing gas and oil. That's one of the common places I see it. You can see it in a gear ratio and other places, but the place I see it most of the time is how I mix my oil into my gasoline for my chainsaws and my boats and other tools that I have around the house. So there are different ways that we can write a ratio. So let's say that we have the fact that we mix 2 gallons of gas for every 8 ounces of oil. And there are 3 ways we can write this. We can write it as 2, and sometimes we put the units in there and sometimes we leave them off, depending on if it is understood the units to be using. So gasoline to oil, it's pretty standard to go gallons to ounces. So we do 2 gallons to, and we use a colon, 8 ounces. I suppose I could have abbreviated that. We can reduce these as well, just as if we were reducing fractions. So we would reduce this actually to 1 gallon to 4 ounces. Or just 1 to 4. So we can use the colon, we can use the words, the word to, because that is how we read that colon, and we can also write them as a fraction. And sometimes, again, we can put that gallon to ounces in there if we want to be more specific. We can also turn this into something we call a rate. So if you wanted to turn this into a rate, we would actually do this division, this 1/4, because we like decimals better than we do, and that would give me that 0.25. And then we write this as a rate, basically gallons per ounce. This little division line is read as the word per. So that's one thing we can do. So we've already done that. So we can write some more ratios. When we write a ratio, this 4.35, for example, to 2.1, when we write a ratio, we like to have them as whole numbers to whole numbers so that they are easier to understand. Because we like whole numbers better than decimals. It's hard to think of 4.35 to 2.1. It's a little harder to grasp those numbers. So what we will do is we want to change them into whole numbers to a whole number. When we're dealing with decimals, what we do is we kind of like what we did with long division, is we're going to move our decimal point to the outside of the decimal. So in other words, to make this a whole number, I have to move it twice. To make this a whole number, I have to move it once. In order to make them both whole numbers, I have to move the largest number of times. So for 35, so we move this one twice, we have to move this one twice. And now what we can do is do our reducing. And I see that there is a 5 in both of them, so I'm going to drag out my calculator a little bit to help me. And I see that this would then be 87, and taking 210 divided by 5 to 42. And I would then look at the 87 and the 42 and see if those can be reduced. And I don't think yes, they can. I think there's a 3 in both. There is. So 29 to 14. So I divided everything by 3 here to get that down. If we have units on there, so this 260 inches cubed to 40 inches squared, we can do some reducing on the units as well. So this inch cubed and this inch squared, so inch cubed is like an inch, 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 and this is an inch by an inch. We can reduce and get rid of 2 of those inches. We can also notice that this is divisible by 20, so I'm going to divide both of these by 20, and so I'll get 13 inches to 2. So taking the 260 divided by the 20 and the 40 divided by the 20, I get the 13 and the 2. Dividing or getting rid of 2 of the inches in each of those just leaves an inch here as well. Let's see what we got on the next slide here. So again, we have 240 people to 16 tables. And I'm going to do it in 16 tables, so we're reducing again. I can't really change people into tables, but I can divide both of these by 4. At least that's what I see to start. So that gives me 60 people to 4 tables. There's still a 4 in there, divided by 4. So I have 15 people on 1 table. Whoops. Or if I were, people. There we go. Or if I wrote this as a fraction, we'd have that as 15 people to 1 table. And I can turn this into a rate, like it says here, a rate. We take this, the number portions, and if I take 15 divided by 1, I get 15, and then I would write the units as a labeling, and it would be people, and then the division line per table. And we see rates all the time in our cars, miles per hour, gallons per mile, things of that nature. Here, this one is a $33 in 4 hours. So $33 in 4 hours. I'm going to take the 33 and divide it by the 4. That gives me $8.25. And I'm going to put the dollar in the front there because that's where we usually put dollars. But it would be dollars per hour. Even though we put the symbol first, we read it second. So this is $8.25 per hour. We'll do one more here. If you drive 243 miles in 13.6 gallons, 243 miles, 13.6 gallons, I'm going to divide those digits, again using my calculator, and I'm going to round it to, let's say round it to the nearest tenth. It was 17.86, so I would round up to 17.9. And then my units would be, again, when we read things left to right, top to bottom, so miles per gallon. Or sometimes we write them as miles per gallon as I was writing it, but this division line is read as the word per. Some difference kind of remind us a ratio in lowest terms is still a fraction, or we can use the words. A lot of times we like fractions, 25 pounds to 3 gallons. If you're turning it into a rate, we actually do it a decimal and round it off, so we would write this as 8.33 pounds per gallon. So when you're doing your homework and your problems, make sure you're answering the questions that they are asking. If they want a ratio, we reduce the whole numbers. They have to be kept as whole numbers. If they want it to be rated as a rate, it's a single number and then the units after. So hopefully this will help you get through this ratio and rate section. I will see you in the next video.